So we basically look at direction, your 16 cardinal points, we look at coordinates, simple basics that we need to know to be able to find places on a map and to be able to determine where to find places, okay, or to go and look for places. The next topic that I want to discuss with you is calculations regarding distance to determine the distance from point A to point B. Now, grade 12, that's why we have a scale, 1 to 50,000. The scale makes it possible for us to determine the distance between two areas, okay? And when we determine distance, because we live in South Africa, just want to get my pen. Okay, because we're dealing with the 1 to 50,000 map, and if we calculate distance, we use kilometers and we use meters. Okay. Now, because the map is 1 to 50,000, I'm going to give you a simple formula that you need to remember. If you want to go and calculate your answer in kilometers, the formula to use is times it with 0.5. Okay. If you want your answers in meters, the formula to use times it with 500. So that's your formulas that you need to use. It's straightforward and simple because the map's been reduced. Now I'm going to give you an example from this map. Now let's assume we need to go and calculate the distance from spot height 788, situated over there, to, they've mentioned over here, a storage dam situated over there. Okay, I just want to use a different color pen because I see they already used green. Now it's straightforward. Because we're working off the 1 to 50,000 map, you place your ruler in a straight line and you measure the distance between the spot height and the storage dam. Now let's assume the measurement with your ruler comes up with 25 centimeters. Now, very importantly, the examiner is going to ask you that you need to present your answer in meters or in kilometers. Okay, but let's say for this instance, we need to provide our answer in both. So what do? You take your 25 centimeters. If you want your answer in kilometers, just want to use a different color pen. It's 25 centimeters, and you times it with 0.5. Okay, straightforward. Use your calculator. 25 times 0.5, and our answer will be 12.5 times. So not 12.5 times, 12.5 kilometers. Okay. If the examiner has stated that you need to present your answer in meters, same story. You're just going to use a different formula. What's that formula going to be? 500. So it's 25 centimeters times 500. Once again, yes, you might be a mathematics pro, but do go and use your calculator. Okay, 25 times 500 and gives me an answer of 12,500 meters. Okay, straightforward. Now while we at it, let me just introduce the orthophoto. Now that's the separate, you don't only get the topographical map, but you also get the orthophoto. Unfortunately, I don't have an orthophoto with me to show you, but I'm sure you know exactly what it looks like. It's a vertical aerial photograph, okay? Bird's eye view taken from above, the one in black and white, okay? But what makes the orthophoto so special? Once again, it's got a scale. So, orthophoto has got a scale of 1 to 10,000. Now, first of all, the examiners do love this question. They tend to ask it in a multiple choice. Is the orthophoto bigger or smaller than the topographical map? Okay, I want you to think about this. Right? Is the orthophoto bigger or smaller? Yes, the scale is 1 to 10,000. But let me explain it to you in the following way. The topographical map has been reduced 50,000 times, whereas the orthophoto has only been reduced 10,000 times. So which one is bigger? Keep in mind, topographical map, 50,000 times been reduced, made smaller. Okay, and the orthophoto, only 10,000 times. So how many times is the orthophoto? I hope you picked it up, the orthophoto is bigger. How many times is the orthophoto bigger than the topographical map? 5 times. Okay, so let's go back. What is an orthophoto? It's got a scale of 1 to 10,000. I just want to add it there. It's a vertical aerial photograph. But, there's a huge but. It's a very special vertical aerial photograph. Why? Because it consists of a scale. That scale over there, it's got information on it. And when I talk about information, contour lines and keys. Okay, such as the references that I've mentioned that's on the bottom of your topographical map. Now, when we look at contour lines, now we also find them. It's these brown lines that we see all over our topographical map. We do find them on our orthophoto as well. Now, what does these contour lines represent? It represents height. It represents altitude. Okay. While we add it, let's just quickly have a look. What else represents altitude on the map? I'm going to write it down there. Very important. Altitude, what defines altitude? It's height above sea level. Okay. So it determines height. The problem we have with a topographical map, with a vertical aerial photograph, what's the disadvantage of a vertical aerial photograph? We can't determine height. Now, a perfect example, if we take a vertical aerial photograph of your school, for example, will we be able to determine which classrooms are double story and which classrooms are single story? No, unfortunately not. We use oblique photographs for that purposes. Now, and it's the same case when we look at topography. We can't determine the height except if we use keys. And the keys that we use is contour lines. Okay. Now, very importantly, spot heights. Trig stations. And benchmarks. Okay, when we look at contour lines, keep in mind we use 2 different types of interval on our orthophoto map, and a 1 to 10,000 map, and a 1 to 50,000 map. That's our topographical map. The contour interval is 5 meters, so each line will represent 5 meters. The next one will be 10. 15 on a 1 to 50,000 map, a topographical map, the contour interval is 20 meters. So it's 20, 40, 60, for example. Now, I hope you've known, discussed it, your teachers discussed it. When the contour lines are very close to one another, what do we know? It's a very steep gradient. When the contour lines are far from each other, it's a gentle gradient. Okay. A spot height is usually a specific area with a little dot, and it represents the actual height in meters. Very importantly, a trig station, very importantly, altitude is always represented in meters. Okay. The unit of kilometers just too big to use, so we refer to meters above altitude. When we discuss altitude, always meters. Okay. Our trig stations, when I get to that, because there's some confusion over there. It's a little triangle, and it's got 2 sets of information on it. Usually there's a bold italic number on the top, and that's the trig station actual number. That does not represent the height. What represents the height? The number on the bottom right-hand side corner 1,400.1. Okay, that's the actual height. And where do we find benchmarks? Okay, usually next to a major route, national route. It's a little angle to show you the height of the actual route. Usually passes where we find it, and it indicates the height, represents the height. Now, there's a difference between the two of them. Pay attention. The interval is only 5 meters on the orthophoto. It's 20 meters on the topographical map. When the contour lines are close together, we know it's a steep gradient, it's a gentle gradient. Altitude, height has been represented and it's been measured in meters. Contour lines, spot heights, trig stations, and benchmarks. Okay, so that makes our orthophoto also special because it's got this information on it that we talked about. But coming back to it, with this information that's given to us, it's also possible for us to go and calculate distance on an orthophoto map. Now, once again, similar to the topographical map, what did we say? If I want my answers in kilometers on a topographical map, I times it with 0.5. If I want my answers in meters on a topographical map, I times it with 500. Okay, formula is going to change a bit, and I'm going to write it down there. If you want your answers on an orthophoto map in kilometers, you times it with 0.1. Okay. If you want your answer in meters, you times it with 100. Now let's assume this is my orthophoto. Okay. And I ask you to go and calculate the distance from spot height 400 to the shop. Okay. Once again, the same principle applies. Matrix, believe it or not, the biggest mistakes that you make in your final question paper, you don't read your question thoroughly. Okay. Instead of using the formula for the orthophoto, you go and use the formula for the topographical map. Immediately incorrect. Okay. So, same applies. You take a ruler and you measure the distance between spot height 400 to the shop. Okay. And let's assume you got 34 centimeters. Now, you've got your distance between the two areas that you need to go and calculate the distance. So let's assume the examiner asks you to calculate your answer in kilometers and meters. So what do? 34 centimeters times 0.1. Okay. Once again, don't be too clever. Go and use your calculator. It's 34 centimeters times 0.1, and you'll get an answer to 3.4 kilometers. Okay. Same applies if the examiner asks you to calculate the distance in meters. You use the distance, the centimeters, 34 centimeters, and you times it with 100. Once again, don't be shy, use your calculator. It's 34 centimeters times 100, and it gives me 3,400 meters. Okay, simple as that. Easy as pie, isn't it? Not difficult at all. Okay, now let's just quickly come to the next calculation. The same formula that we're going to use it twice, and that's an area. Okay, let's go back to our map on the top. Now, we've done that, calculating distance. Now let's just quickly look at the area. Now by now you should know the formula for area is length times breadth. Now, for instance, let's assume they ask us to go and calculate the area of this little purple block over there. let's make it even better. Let's use a bigger block. Let's use this blue one over there because it's going to be difficult to write on there. So let's assume that the examiner asks me, pay attention, what map are we using over here? The 1 to 50,000 map. So let's assume the examiner asks us to go and calculate the area of this blue block in grid D1 to 3 and E1 to 3. Now the same principle counts when you calculate the distance. You're going to need your ruler to be able to determine the length and the breadth. Okay, so let's get going. So let's assume they ask you to go and calculate. And we measure the length. And let's make it 12 centimeters. And we go and measure the breadth. And let's say it's 6 centimeters. So we got the information, but keep in mind, we're working off a topographical map. There's a formula involved because the map has been reduced. So the length is 12 centimeters, the breadth is 6 centimeters. So we got our information because we used our ruler to measure the distance in between them. Let's go and do the calculation. Now let's assume you're asked to go and calculate in kilometers. So area equals length times breadth. Okay, and we've measured the length of that square on the topographical map. It was 12 centimeters. Now the question stated, calculate the area of the square in kilometers. What's our formula for kilometers on a topographical map? 0.5. And what did we get the breadth? It was 6 centimeters. And because we're working with a formula, we're working on a reduced map, so we need to times it with 0.5. I just want to draw the area over there. That was 12 centimeters and that was 6. Okay. Now, first of all, what do? You get out your calculator. 12 times 0.5. Whoops, made a mistake. 12 times 0.5. That gives me 6. Then we look at our breadth. It's 6 times 0.5. Correct answer is 3. Okay. Now, 6 times 3. I'm not going to use my calculator, but I should actually. It's quite easy enough. It's 18 square kilometers. Okay. And that's your final answer. Matrix, that's how simple it is. Okay. For some reason, you calculate. Many of you make the mistake by taking the 12 and multiply it with the 6, and then afterwards using your formula. Unfortunately, it's incorrect because you're dealing with a formula because the map is being reduced. Now, the same counts for your orthophoto. Now, let's assume this is your orthophoto. Okay. And we need to go and calculate the cultivated land. Okay. Cultivated land, what type of activity is it? Let's revise a little bit. It's a primary activity. Okay. Cultivated land, it might be commercial farming. Okay, and we go and measure the distance. Now remember, this is our orthophoto map. Scale is 1 to 10,000. So we go and measure the distance. Let's say we got 24 centimeters. And our length is 24 centimeters. How did we get it? You place your ruler and you measure the length. And this was 3 centimeters. Now, once again, the same applies, but we're going to use a different formula. Area equals length times breadth. What was our length? It was 24 centimeters. Okay, let's assume the examiner asks us to calculate the area of the cultivated land in meters. Okay, so what's our formula going to be? 100. If it was kilometers, 0.1. Okay, so 24 centimeters times 100 times, what was the breadth? 3 centimeters times 100. Okay, so once again, use your calculator. 24 times 100 equals 2,400. Okay, times 3 times 100 equals 300. And only now do you calculate the length of the breadth. Okay, so it's going to be one massive square meter. It's 2,400 times 300, and that gives us 720,000 square meters. Okay, so the same principle count when you do this calculation of distance and area on your orthophoto and topographical map. You're just going to use a different set of formula. Okay, topographical map kilometers 0,5, meters 500. Orthophoto kilometers 0,1, meters 100. Okay, let's move on. Now our next calculation that we can go and pay attention to is the magnetic declination. Okay, now what is the magnetic declination? It's the magnetic north declining every single year, because unfortunately when we use a compass we look at magnetic north, we do not look at true north. So we want to see by how many degrees or minutes was there a declination every single year. Now all that information is usually given to you. Okay, you just need to go and determine the present year, or it might be a different year the examiner asks you to go and calculate this set of information. Now where will you find this information? Now for instance, if you look at this Worcester map, the magnetic declination has been presented on the left hand side corner. Okay, as you can see. Unfortunately, it's a bit unclear over there, but they've managed to give it over there on the side, break it down on the side. If it's not found on the left-hand side of the map, it's usually on the bottom below the map, just between the map and the references, where they provide you with the magnetic declination. Okay, so what it will usually look like, they will provide you with the magnetic declination. I'm just going to use my own one. So let's just use Johannesburg as an example. And let's say we have our Johannesburg map, and they will give us the magnetic declination. And they will tell you the magnetic declination for Johannesburg is 28 degrees, 14 minutes, usually west, and the map was drawn in 2001. That's quite important. Okay, that's the first set of information that will be given to you. The second set of information is the annual change. Okay. Now, first of all, let's just define annual. It means yearly. Okay. The annual change, let's assume it's 6 degrees west. Now, very important over here, and I want to add it immediately over here. If we look at the annual change, I'm just going to put it here in a little block because it's like a little formula. If it moves in a westerly direction, once we do the calculation, we're going to add. When it moves in an easterly calculation, we're going to subtract. Now, this is quite important because this is the information that's given to you. And the question will state, calculate the present. I'm just going to write there magnetic MD for Johannesburg. MD stands for magnetic declination for Johannesburg. Okay. Now, very importantly over here, calculate the present magnetic declination for Johannesburg. We want to know what's the declination currently for Johannesburg. So what year are we? 2020. Okay, the year for 2020. A year that all of us actually wants to forget. But anyway, let's continue. So, the year 2020. Right. Now, the question is, it means pay attention to the date. This map, when the declination was 28 degrees, 14 minutes west, it was in 2001. Okay. So that means that was the declination back in 2001. But every single year, it has moved 6 minutes west. So we need to determine the present. So what are we going to do? We're going to take 2020 minus 2001. And that's going to leave us with 19. Because this map was drawn in 2001. Okay. Now, if we continue, every single year it's changed 6 minutes to the west. So what do we do with that 19? Times it with 6. Okay. 19 times 6 equals 114 minutes. Now, can you remember when we started this lesson? We looked at coordinates. We talked about degrees, minutes, and seconds. Same principle applies over here. Do we talk about 114 minutes? No, we don't. Remember this formula. 60 minutes equals 1 degree. So 114 minutes equals what? We take 60 off there, it's going to be 1 degree and 45 minutes. Okay, so it means the magnetic declination from 2001 to 2020, okay, happened to 1 degree 54 minutes. So what do we do now? Because it's moving west, what are we going to do? We're going to say the following. 28 degrees, 14 minutes, plus 1 minute, 54. Okay. So what do? We've got 8 over here. We got 68. Unfortunately, it's only 1. So it's going to be 30 degrees, 8 minutes.